The square root property also holds when the thing being squared is itself an algebraic expression. So we treat it exactly the same way as we did the previous problems. So first, let's get the thing being squared isolated. So we'll add 16 to both sides. So x plus 1 squared equals 16. So this means that x plus 1 is equal to the square root of 16, or x plus 1 is equal to the negative square root of 16. So x plus 1 equals 4, or x plus 1 equals negative 4. Subtract 1 from both sides, and we get x equals 3, or x equals negative 5. And again, plug either one of these answers into the original equation, you'll get a true statement. For instance, if we stick 3 in here, we get 3 plus 1, which is 4, squared is 16. 16 minus 16 is 0. So if we have x plus 1 squared plus 25 equals 0, we want to subtract 25 from both sides, giving us x plus 1 squared equals negative 25. Now we apply the square root property. So x plus 1 is equal to the square root of negative 25, or x plus 1 is equal to negative square root of negative 25. And thinking back to our work with complex numbers, we remember that the square root of negative 25 can be written as the square root of 25 times the square root of negative 1. The square root of 25 is 5, and the square root of negative 1 we signify with lowercase I. So the answer becomes 5i. So x plus 1 equals 5i, or x plus 1 equals negative 5i. And then you subtract 1 from both sides of the equation. So x equals negative 1 plus 5i, or x equals negative 1 minus 5i. Be sure to write your answers in the correct complex number form as used in this example, where we write the real number first, the imaginary number second.